Okay, it's good to see everyone. Hope you're having a good day. So our plan today is to go ahead and run through problems on homework that is going to look like this. This is from the lesson prior to the Thanksgiving break, the 3.13. So I'm going to run through and kind of look at some pre-chosen problems, kind of talk about the main key points and ideas, hopefully getting you ready for the quiz tomorrow over this material. Now, next week, on Friday the 13th, you've got your second exam, but it won't cover this material. It's going to cover the current material that we're talking about for polar equations and graphs, what we were talking about Monday and Tuesday. And we should be able to wrap that up on, actually, if not tomorrow, then definitely by Friday. All right, remember tomorrow morning by 8:05 is the deadline for the Trig equations quiz. If anybody's interested in retaking that, I'm still here after school, or I'll be here in the morning. You got to have the homework assignment turned in before that. And you got yourself the note card for the exam. I think this is the earliest I've ever given it to you, but I wanted to give you maybe some more time this go around. Whatever you want to put on here for next Friday. So this is for the exam, not the quiz tomorrow. So whatever you want to go ahead and write on this front and back, you are free to do so. And don't forget, coming up next week, Tuesday, Thursday, we've got the TSIA. So I don't have any more information about that unless anybody has any questions. Maybe I can help you out, but anything on anybody's mind? Okay, well, let's go ahead and get to it. So the first page here, it'll say Worksheet A 3.13 at the top. Did anybody need a copy? Okay, folks, okay. Glad I asked before I got started. Anybody else? Okay. Now, I hadn't originally chosen any of the first three problems. This is just plotting points, but would anybody like to review plotting a point in a polar grid? Okay, then we're going to go ahead and move on to the first one I have, which is number 4. And then by the time we're done, if there's any question that you still want to talk about, let me know. We'll go back and we'll talk about it. Remember, the whole key is posted to the website. So I'll pull up my notes here. Okay, so number 4, it says the location of a point in the plane is given by this polar coordinate, 4, 5 pi over 6. Write 2 different representations for this point in polar coordinates. We're going to change this. We're actually going to do it with 3 points, just like we did on the notes before Thanksgiving. So we're going to go ahead and write 1 point where that radius is going to stay the same. And then we're going to write 2 additional points where that radius is going to change signs. Okay, so we're going to keep it for 1, and it is, yes. I thought, did I hand out the wrong paper? Well, that is weird. Those are like that too. Ooh. Guess something happened with the, maybe it didn't take one of the pages. Looks like, all those, is yours the same read? Okay. Okay, this one's good. This one has a 3. But as for, I apologize. Looks like one page didn't go through the copy machine. So I have one that has 3. Does it matter who gets it, or yeah? Nah. Oh, you want the paper? Okay. As far as the other folks, I do apologize about that. I guess just maybe write it out someplace, but sorry about that. I didn't even notice until you said something. Wow. Okay. So let's see here. We want to go ahead and write 3 additional points for 4, 5 pi over 6. Now, if you want to keep the sign of your radius the same, so with this first point, we want to keep the 4 a 4. What we're going to do is revolve. Okay, we're going to rotate a full revolution in the opposite direction to my angle. Now, when I say a full revolution, you know, we're talking about 2 pi. And because we have a positive 5 pi over 6, okay, the opposite direction would be to go ahead and subtract that. But now remember, even if I were to go ahead and add 2 pi, that's still going to be a location of that point. There's an infinite number of ways to write a polar coordinate for one location. Okay, so this problem just comes down to a little bit of algebra. We'll go ahead and get a common denominator. So this is going to be 5 pi over 6 minus 12 pi over 6. So how many 6s would I have here? Okay, so a negative 7 pi over 6. There we go. So both of those would be plotted at the exact same location. Now, if I want to go ahead and change the sign, in this case from positive to negative, or even, negative to positive, how far am I going to rotate? Only what? Anybody remember? What's that? Pi. We're only going to go half a rotation. That's exactly right. So you might remember in the notes before the break, we actually condensed these. We just added and subtracted pi. Okay. So half a rotation in either direction, then that's going to keep the sign changed. So I'm going to go ahead and multiply by 6 over 6. So I got 5 pi over 6 plus and minus 6 pi over 6. Okay, so let's do the sum first. 5 pi plus 6 pi. Okay, so 11 pi over 6. And the difference. 5 pi minus 6 pi. Negative pi over 6. There we go. So I got 3 points. They're in the same location as the original one. Okay. All right, so questions about that? Okay, good. Off to a good start. Okay, now we're going to go ahead and skip to number 10. We're going to go ahead and skip to number 10. You folks have 10? There we go. So it was only that one page. It's so weird. $11, and yeah, that is unusual. Okay, so let's see what happens. All right, so number 10. The location of point A in polar coordinates r theta is 2, 5 pi over 3. Which of the following describes the location of the rectangular coordinates x, y? So this is a conversion problem. We want to change polar to rectangular. So the first thing we need are my formulas. And the mathematics behind it, it's not difficult. I don't think that's what's going to catch anybody, if anything, on this quiz. I think it's just remembering those formulas. Okay. Anybody help me out? Okay. I need to use this radius and this theta to find x and y. So x equals, y equals. Anybody remember those formulas? Hey, Vera. Okay, so the radius times cosine of theta, that is x. And what about y? R times the sine of theta. There we go. That's what you're going to use if you want to go from polar to rectangular. Now, this is going to be very straightforward. There's only one way to write a rectangular coordinate, so you're going to get the exact answer. Now, going from rectangular to polar, that's a little trickier because there's an infinite number. Okay, so let's go ahead and substitute in. So the radius is 2 times the cosine of 5 pi over 3, and we have 2 times the sine of 5 pi over 3. Now, if anybody knows the value of the trig function off the top of their head, or should we go ahead and diagram it? Okay, let's diagram. So 5 pi over 3 is going to be in the fourth quadrant. So let's say it goes around like this, 5 pi over 3. Okay, right. What's the reference angle? Pi over 3. There we go. And if anybody's not seeing immediately where that comes from, remember 5/3 pi, that's 1 2/3 pi. So here's the 1 pi. So this is 2/3. We need an additional 1/3 to get to the x-axis. So we go ahead and draw the angle. Okay. We go ahead and use that to create a right triangle. Remember, the reference angle tells me what kind of triangle we're working with. This, of course, is a 30, 60, 90. Let's say that hypotenuse is 1. What was across from 60? What fraction? Okay, root 3 over 2. Now, because we're in the fourth quadrant, I'm going to go ahead and make that negative. And then what was across from 30? 1/2. Okay, so see, I've got my x, I've got my y. I can evaluate those trig functions now. Okay, so this is going to be 2 cosine of 5/3 pi. That's a 1/2. So I know that my x value's got to be 1. Okay, so A is good, B's out, C is good, and D is out. Okay, remember, whatever you can do to go ahead and eliminate some answers is always a good thing, especially when it comes to the AP exam. Now for the second one, sine of 5/3 pi, that's a negative root 3 over 2. So that's going to be a negative root 3. And my answer is what? C. Now, there are other ways to look at this. Like, let's say something very similar to this shows up on the AP exam. Well, you don't remember the formulas. Remember, use whatever you can to go ahead and eliminate answers. This point right here would be in quadrant 4, right? Because not only is 5 pi over 3 in quadrant 4, but the radius is positive. Well, if I start looking at my answers, the one I'm choosing has to be in the exact same quadrant. What quadrant is A in? Yeah, they're both positive, so that's not even in the right quadrant. I wouldn't even consider that one. Okay, so there's always ways to go ahead and look at these. All right, how we doing? Good so far? Okay. Well, we got 10. Let's go ahead and jump to 16. And yeah, I do apologize. I have no idea what happened. I've never seen that happen with my stuff before. Mm-hmm. Oh, yeah, sure. You got your badge, right? Okay. And iPad's right over there. Okay, so 16. Now we're going to reverse that process. So we're going to go from a rectangular point back to a polar. Okay, so we want to change negative root 2 to polar. All right, so there's 2 formulas I need here. For polar, we need the radius, and we need the angle theta. Can anybody remember what the radius should equal? What am I going to do with x and y to find it? It is coming from the Pythagorean theorem. Okay, we're going to say that the radius is the square root of x squared plus y squared, because r squared equals x squared plus y squared. Exactly. Good, good, good. Now for theta, does anybody remember what trig function we're going to use? We got to use tangent. And because we're looking for theta, we're going to take its inverse, y over x. There we go. So there are the formulas we'll need for this type of problem. Okay. Well, for finding the radius, that's going to be pretty quick. It's just substitution. Excuse me. So the x, a negative root 2 squared, plus the y, a negative root 2 squared. All of this is below the radical. Okay. So what is a negative root 2 squared? Oh, 2. There we go. So 2 plus 2, this is going to give me square root of 4. So my radius is 2. So my radius is 2. So we got half of what we need. Now, let's go to theta. So I'm going to go ahead and take y over x. So theta is going to equal tangent inverse. Well, if I take a negative root 2 over a negative root 2, see, that just gives me 1. Okay, so tangent inverse of 1. So we got to remember how to work with tangent inverse. Okay, Matthew, what 2 quadrants was tangent inverse restricted to? Oh, now that's good that you remember that, but remember that's for solving equations. All students take calculus helps us know in what quadrant the trig functions are positive or negative. Okay, so that's good, but not what we're after. Okay. So tangent inverse can only be in 2 quadrants. Anybody help me out? Harrison? It's 1 and 4. Remember, it can only be in 1 and 4. You will never, 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 never find tangent inverse in 2 or 3. It's not possible. Okay. So in this case here, where am I going? 1 or 4? Why 1? Because it is positive. There we go. So I'm going to draw my triangle here. Remember, tangent is y over x. So there's my y, there's my x. The hypotenuse would be the root 2. So what kind of triangle do I have here? This is 45, 45. So remember, I'm going to rotate from standard position. That's a 4 right there, even though it looks like a y5. So 45 degrees, what I should be getting is pi over 4. Okay. Here's where you got to be careful. I'm going to go ahead and put my 2 items together. So according to my information, I came up with 2 pi over 4. That is not any of my answers. Did we make a mistake? Now, if we didn't make a mistake, let's go back to the original. Where is this point? What quadrant? It's in quadrant what? Quadrant 3. They're both negative. So this is in quadrant 3, so I've got my point. Let me go ahead and get this out of here. So my point is going to be somewhere here in quadrant 3, but we're over here working in quadrant 1. Okay. So what we're going to do, and I think I'm a little off there, but what we talked about before the break, if I go ahead and take my hypotenuse, if I extend it, it should intersect that point. Or, well, it will intersect the point. It's just that I didn't estimate that very well when I did that. Okay. So you'll notice if this is 45, this angle here is now 45. Basically, by extending this, all I'm doing is taking the angle I found and adding what? Pi, 180 degrees, yeah. So if I rotate all the way around here, 180 plus 45, that's 225. What's that as a radian measure? There we go. So 2 and 5 pi over 4, that's the answer I'm looking for. See, that's why you got to be careful. Okay. Now, the pi over 4 would work if I made the 2 negative. Okay. So remember, what happens when you have a negative radius? It goes the opposite direction. So if I were to go ahead and rotate to pi over 4 right here, instead of heading from the pole towards pi over 4, it would push me in the opposite direction. See, that's where I need to be. Okay, but even if I did that, that's still not one of my options. Okay. All right. How are we doing? Any questions on going from rectangular to polar? Why is it A? Because once we went ahead and extended this line right here, and we found what our new angle should be, 5 pi over 4, that's the only angle that matched up with our radius. And we can even go through, I mean, let's take a look. We know our points in quadrant 3 here. Let's take a look at B. Okay. 7 pi over 4 with a positive radius. What quadrant would that be in? Okay, that'd be in quadrant 4. So this one here, well, it's in quadrant 4. Remember, we're looking for quadrant 3, so that one's already out. Okay. Now, this one right here, the good news is 5 pi over 4 is in quadrant 3, but what happens with the negative radius? It pushes it in the opposite direction, so this is actually in quadrant 1. So that's why C is out. Okay. And then what quadrant is D in? It's in 2, because 7 pi over 4 is in the 4th quadrant, but again, the negative radius pushes it the opposite direction. So, I mean, even if on like this one, you forgot the formulas, I mean, there you go. You could still just eliminate all those. Now, I would imagine on the AP exam, you might be able to eliminate 1 or 2, but I don't think it'll come down to you could eliminate all the answers except the correct one. I don't know. At least on the practice test I took, that didn't happen. And this is only the 2nd year, so maybe they're still perfecting it. Okay. But Akil, does that help? Okay. All right. Cool. Okay, so the next one is number 18. We didn't work 18, did we? Because I remember some classes did work it that Friday before the break. Okay. So let's talk about the complex plane. A complex number is represented by a point in the complex plane. The complex number has a rectangular coordinate of negative root 3 over 2 and negative 1/2. Which of the following is one way to express the complex number using its polar coordinates? Okay, so a quick review. We actually went ahead and plotted these imaginary numbers, these complex numbers, in the imaginary plane, but it looked just like your normal rectangular plane. The horizontal axis was the real, and the vertical was the imaginary. Okay, like for example, this one right here, using this x and this y, we had the version x plus yi. So that would be negative root 3 over 2 minus 1/2 I, if we wanted to write that as a complex number. Okay, does that kind of sound familiar? Okay. Well, does anybody happen to remember what the polar form of a complex number is? It's just one expression. Okay. That's okay. That's okay. So that's why we're doing this. So the polar form of a complex number looks like this. R cosine of theta plus R sine of theta I. Now remember, I is not with that theta. It's sine of theta, and then that evaluated times I. So if you want to go ahead and say like plus IR sine of theta, there we go. Now in this case here, if I want to write that, all I need are the radius and theta. So this is going to be what we did on the previous problem. Remember, the radius was the square root of x squared plus y squared, and theta was going to be tangent inverse of y over x. Okay. So what do you say I go ahead and get this problem going, and then we have somebody come up and finish it for me? Okay, a lot of smiles out there. Cool, 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 cool. All right, so the first thing we need, let's find the radius. So it's just substitution. Okay, so we are going to have that negative root 3 over 2 squared plus negative 1/2 squared. All of this is below the radical. Okay. In fact, let me go ahead and move this out of the way. That probably just be better. Move this down here. Okay. So if I were to go ahead and simplify this, the square root of 3 over 2, that negative squared, that's going to be 3/4. Negative 1/2 squared, that's a plus 1/4. Don't want parentheses, I want a radical. So anybody tell me, it looks like my radius is going to be what? Yeah, square root of 1 is 1, because 4/4. So I've already got half of what I need. Yeah. Oh, Catherine. So I'm looking at my answers here. That only allows me to eliminate D because this says we have a radius of 2. All the rest of these, there's nothing in front of cosine or sine, so have to assume it's a 1. Okay, so at least we got a 1 and 3 instead of a 1 and 4. Now what we want to do is take tangent inverse of y over x. Okay, but before we can even look at the inverse portion, we need to know what is y over x. So we need a negative 1/2 divided by the negative root 3 over 2. Once we have that, then we can go ahead and plug it in here. Okay, so at this point, I'm sure you're tired of listening to me. You want to come on up and show me some math on the board. Who wants to do so? Okay, oh, Vera, you want to do it? Sure. Okay, I was going to spin the wheel, but okay. Yeah, so we need to simplify that first. Okay. Okay, so we're multiplying by the reciprocal. That's going to give me 2 over 2 root 3. So it's 1 over root 3. Okay, and she went ahead and rationalized. Good. So this is what we need. We need tangent inverse of that root 3 over 3. So quadrant 1 or 4? Quadrant 1. Okay. Okay, so there's your y, there's your x. What would the hypotenuse be, just for argument's sake? Just to go ahead and write. I know we're dealing with a 30, 60, 90, but I'm sure somebody wants to see the hypotenuse, right? Yeah, I heard a yes. There you go. Okay. So what would the hypotenuse be? Remember, you take the shorter leg and double it. So would that be 2 root 3 or 6?
Wait, sorry, what?
So in a 30, 60, 90, we know we take the shorter leg and multiply it by 2. So which one is the shorter leg? There we go. So it'd be 2 root 3. There we go. So because that is the shorter, that means that this right here, what is that? Oh, okay. That's 30 degrees. Okay. So tangent inverse of root 3 over 3, that is pi over 6. Okay, good. I'll take it from here. Thank you, thank you, thank you. Now here's the thing. Just like that last problem, I'm looking 5 pi over 6, 7 pi over 6, 4 pi over 3. We didn't get the answer that's there. So that doesn't mean we did anything wrong. Okay. Remember, this triangle that she created would have been in the first quadrant here. So here is the 3, here's the root 3, there's the 2 root 3, here's the 30. Okay. But remember, our point, if we go back to it, negative, negative, our point's going to be in that third quadrant. Okay, so what did we do on the previous problem? Yeah, just extend it. And remember, if you're not interested in doing that, just take the angle you have and add pi. Okay, but if we're going to do it this way, we got 30 and 30. Let's rotate over. So 180 plus 30, that's a 210. And what's 210 as a radian? 7 pi over 6. Now there is, again, thinking about the quadrant, okay, you could use that to go ahead and eliminate one of the answers. If you take a look at what's left, okay, ooh, whoa, that's not what I meant to do. There we go. What quadrant is 5 pi over 6 in? That's in quadrant 2, but again, remember, our point that we're working with is supposed to be in quadrant 3, so there's no way that angle can be correct. Okay. Now C, 4 pi over 3 is in the third quadrant, so this one, we would have had to do the math to figure out which one was correct. Okay, how are we doing? Any questions? Anybody having a hard time? And what time are we at here today? 20? Oh, we got plenty of time. Okay. All right, let me go ahead and erase this. So how are we feeling so far? Are we starting to feel a little better about that quiz tomorrow? Okay. Like I said, I really don't think it's the amount of time that's passed that's going to catch people. I think it's just remembering those formulas. Okay, remembering what to do in each of the situations. Okay, well, let's look at the next one, 19. So this one, we're going to reverse it. So let's say we have a complex number that's a polar form, and we want to go back to just a rectangular complex number. Okay, so we have 2 cosine of negative pi over 3 and 2 sine of negative pi over 3. Well, going back from polar to rectangular again, that's going to be really easy. What would I do here? Okay, why did I highlight those? Okay, in a matter of speaking, all we got to do is evaluate them. Okay, because once I simplify 2 cosine of negative pi over 3, that's x. Okay, once I go ahead and simplify 2 sine of negative pi over 3, that's your y. Okay, so let's see. Negative pi over 3 is going to be in the fourth quadrant. Okay, remember we rotated clockwise to get there. Okay, so I'm going to use this to create a right triangle. Hypotenuse is 1. I always forget. What's across from 60? Okay, that root 3 over 2. And across from 30, there's your 1/2. Okay. All right. Now we just got to simplify. So this 2 cosine of negative pi over 3, that's actually 2 times cosine of the angle is 1/2. So it looks like my x value is 1. Okay, so A and B are good. Immediately gets rid of C and D. And now we got to do the same thing for the other one. 2 sine of a negative pi over 3. So that's 2 times what? Negative root 3 over 2, which is just a negative root 3. So my answer is what? All right. Questions? Okay. Okay, we've got one problem left. I know, I'm sad too. All right, let me go ahead. Yeah. Yes, this review today, this is what's on the quiz tomorrow. Only this stuff, not what we were talking about the other days. That is actually coming up next Friday for the exam. Okay. Yeah.
Where'd she put the 5-3 from?
Oh, I got it right from here because they were giving me the angle negative pi over 3. So that's the angle that I went ahead and graphed. Okay. All right. So let's go to 22. This is our last one. So this has the biggest formula. This is finding the distance between 2 polar points. Okay, now remember the distance was going to be this huge radical. Okay. So I'm going to go ahead and go around the room, and each person I call on is going to give me one part of it as we go through. Okay, so what is the first item in my radicated? Don't know? Okay. Marina. No. Akil. Reed. The end, we're going to subtract thetas. Okay. That's all you know? Really? X. Oh, no X. Okay. Right. Nobody? Yeah. No, there is a -2 in there. Okay. So here's the formula. So you're going to take the first radius squared plus the second radius squared. Then we subtract 2 times the first radius times the second radius. And then as Audrey said, we finish up with cosine of θ2 minus θ1. Remember, it was the big, you remember this, right? Oh, so Matthew, okay, here we go. Okay. So Matthew, can you reproduce it for me?
I just know the formula. I can't do it.
Oh, okay. All right. So there we go. All right. Now, this formula will work with either radians or degrees. It actually does not matter. I would encourage you to work with the radians. I mean, we want to keep the calculator in radian mode, and we got radians here. So really the only thing we have to do first is just figure out what the difference is. So which one would you like me to start with? The 2/3 pi or the -5/6 pi? Which one do you want to go first? Okay, Quinn, what do you like? Okay, so I'm going to go ahead and take 2/3 pi, and I'm going to subtract the -5 pi over 6. Okay. But because we chose to go this direction, what happens when we subtract a negative? We're going to add it. Okay, so I'm going to get a common denominator. Multiply this by 2 over 2. So we're going to get 4 pi over 6. 2 negatives make a plus. 5 pi over 6. So how many 6 do I have? Okay, 9 pi. And this one can actually reduce. So we're looking at 3 pi over 2. Now, I do have a question. If I had reversed this, if Quinn had told me to start with the negative 5 pi over 6, if I subtracted the 2 pi over 3, it would have given me a negative 3 pi over 2. How would I know which one to plug in, or does it matter? It doesn't matter. What kind of function is cosine? It's even. Remember, cosine is even, so one of our identities, cosine of negative theta equals cosine of theta. So whether I choose to put the negative in or not does not change your outcome. Okay. All right, so we've got my difference here. Let's plug everything in. Let's see what we got. So control divide. Here we go. So 7 squared plus, now especially if it's a negative radius, I would encourage you to go ahead and put that in parentheses. Minus 2 times 7 times negative 2 times the cosine. And what do we get? 3 pi over 2? 3 pi over 2. There we go. Okay, so let's round this to the nearest hundredth. Okay, what should I get when I push enter? Anybody? I hear a lot of buttons being pushed. Once we get this, we're done. Okay, 7 point. That's all you got? Okay, so highlight it and push enter. Maybe it's the settings on your calculator. Did he give you any decimals? No? Ooh, that's weird. Okay. 7.28. Okay. There we go. How many people got that? Well, look at all those hands going up. Why didn't we say anything? Okay. And Matthew, you were talking about you could reproduce the formula. You did. You did. Oh, the calculator. Okay. Yes.
Okay, so since it was 7, would I have got it wrong? Like if I was on 6? Because I don't know what I put in wrong.
Oh, I see where it was. Okay. So it took me a second to find it, but if you come through here, see, you multiplied it by -2.
Oh.
So that needs to be just -2. There you go. There you go. All right. Okay, so I do have to ask, were there any other questions on the assignment we wanted to take a look at? Five or six, somewhere around there? All are multiple choice but one. The one that has no answers written down. All right, any other questions? We get out at what, 20? So we got about 5-6 minutes. You'd have to go super fast, and if anybody leans in and says, hey, is anybody in here, make sure to call back. I heard about a student who did not.